So, we're gonna do a little experiment in here. This is a deck of playing cards, sealed. Open. Let's see. There we go. Right there. I did it. There we go. All right. Get this bucket cellophane off. Break the seal. Fresh deck of cards. Okay. Take out the jokers. We don't want jokers in here. Let's shuffle them up. Let's try to shuffle them up. All right, so I have a proposition for you. Got this brand new deck of cards. And we're gonna play a drawing game if you wish to play. You will draw on behalf of the entire class. I will let different people draw. If you draw a red card, you will get 2 extra credit for the final. Everybody will get 2 extra credit for the final. If you draw a black card, however, there's got to be consequences. There will be another question on the final. Which isn't really bad, because like the more questions you have, the less each question is worth. And so like if there's only 2 questions, if you miss one, you failed the final. If there's 100 questions and you miss one, you've got a 99%. So like more questions isn't bad. Does anybody want to play this game? Yeah. All right. Four spades. Oh. No. How to get started? Why you gotta do that? Want to do back here? Just button it up for everybody. How many little people? Right? These spades. Ah, king, but it's still black. That's not good. Anybody else? No, you don't think you're lucky. It just means that you have more opportunities to prove what a badass you are.
Was that 3 extra questions?
That's 3 questions. All right, I'll put it in favor for you. We'll leave this card out. I'll put it upside down on the bottom. Now. There's less black cards than red cards, right?
Are there really red in there?
Some,
I didn't have red and black in all decks, right?
red card all decks.
I'm like, is it it's weird.
I didn't see you. That's 4. Oh.
People keep getting cards. I was like, I just printed one.
26 of them and all 26 of them.
What else? You already giving up on me? Shit. All right, we'll stop at 4. That's fine. There's nothing wrong with that. Why did you wanna stop?
No one's looking.
Feeling unlucky? Alright, we're gonna do it. What is this? Count me in. Alright. Maritza says draw one for her. So I will. That looks good.
Oh my god.
We're up to 5. Not bad, nothing wrong with 5. You guys gotta get one. Let's do one more. You gotta get one, right? All right, we'll try that one. Come on the fuck.
Oh,
All right, so this is fucked. You guys are fucking really unlucky. That's phenomenally unlucky. Yeah, like I don't even get it. So we're gonna use this as part of our lecture today. All right. I got a slideshow. I will load the slideshow into Canvas. So you don't need to like pause and like write down all the shit right now. Because it is Halloween night. So we can spend 2 hours doing this lecture, or we can spend about an hour. And then you can do the notes on another day. Up to you guys. So hypothesis testing. Oh. Just to be clear. So there's red cards. So this whole insinuation that I would be dishonest, that's just fucking hurtful. It's just hurtful. All right, back to the hypothesis testing. This is chapter 10. This presentation I actually earned my full-time job with. It was my lecture. You have to give a lecture when you're applying for a full-time position. March 7th, 2018. That's not when I did this thing. That can't be. Maybe it is. It's been a while. Slideshow from beginning. Your teacher offers to make you a small wager. You will draw a card 6 times from a standard 52 card deck, replacing and shuffling the deck after each draw. If it's red, the class wins 2 extra credit points. If it's black, oh, I said your final review will have 2 extra problems. I changed that. I wanted it to mean something. A lot of you won't even do their final review, so I said an extra question on the final. We're up to 6, by the way. That's not 6. I'm wiggling 4 fingers and I said 6 because I'm good at math. Right.
you ever seen Shrek?
Pick number 3, my lord. Pick number 3. Fucking love that guy. Have I ever seen Shrek? Has anyone not seen Shrek? Oh, you are missing. Like the first one is really good. Other ones, they're decent, but the first one, like I went in with I did go in with a really fucking very little expectations, like a cartoon. I didn't see it when it came out. I waited till it like was on like DVD or some shit like that. I didn't go see it in the theater. And then I saw like, oh my God, everybody was right. Finally. Like everybody said Shrek was great. And like normally they're not all right. All right. You drew 6 black cards in a row. Did I hustle you with the stack deck? I think we just showed that I didn't. But let's pretend that you didn't show you the fuck. I wasn't supposed to show you the deck yet. I got a little excited.
It's the exact amount of cards that we got. 6 blacks. It's a little spooky.
So this is like a little spooky, right? It is spooky. It's Halloween. You're supposed to have spooky shit. So what is the probability of drawing 6 black cards in a row? Each card is 50%. Well, let's pretend I didn't put them on the bottom and try to improve your odds, even though you guys still fucking suck. Let's say it was 50% each time. And it's like the first is black, or the second is black, and the and turns into multiplying. We have multiplication here. You get about 1.6%. You guys were ready to stop at 5. I pushed you to 6. Because that's just who I am. 5 would have been about 3.2%. If you'd stopped at 4, it's about 6.4%. It's like doubling that way. It gets a little bit higher each time. So in 1,000 trials, we could expect to see 6 black cars in a row about 16 times. Might be 15, might be 20, but somewhere around 16. This is possible, but it is highly unlikely. You're right. I agree. There was reason for some suspicion after a little while, but I think you said like after 2 cars, which is some bullshit. So outcome, I'm either really lucky. I don't know. Am I really lucky? I just fuck myself. I have to grade more problems. This is wrong. I'm not really lucky. The question was, are you unlucky? Or was the deck stacked against you? Were your odds of winning not even? Were you conned? This is the idea of hypothesis testing. Hypothesis testing, we're going to make an assumption about reality. We assume something to be true. Usually we're going to base it on previously collected data and what someone found out 20 years ago and go, is that still real? Or we might just have our own fucking wild ideas on what's going on and we're going to figure some shit out. Then we're going to gather sample evidence and analyze results to see if it supports our idea. That's hypothesis testing in a nutshell. That's how it is in scientific hypothesis tests when you're doing like science projects. You have an idea of how this project should work. You do the lab experiment, you see how it works, and you make a result. We're doing the same thing here. A hypothesis statement, what is it? I haven't really said what it is. It's a statement about a characteristic of one or more populations. The things we're going to focus on are population parameters. Population parameters include proportion, they include mean, standard deviation, and there's ones for variance, but we're not going to do variance in this class. Again, I will put these slides up, so try to enjoy and absorb the experience of it and appreciate like that rather than trying to cram the knowledge down. You can always look at these later, I promise. So let's look at the way hypotheses work. I've got 3 examples, one for proportion, one for standard deviation, and one for mean. This one says the percentage of milk fat in California dairy milk in 2012 was 3.72%. Researchers believe that a change in diet has changed the percentage of milk fat content. What population parameter is this statement about, and what is the claim? Say that again?
California and the,
California is the state.
oh, I think like world population region.
No. Like, what parameter are we talking about? Proportion, mean, standard deviation?
Oh, 3.7.
What is that?
The wouldn't be like the
Percentage of milk
deviation
fat.
of research.
It's a percentage. What kind of parameter is that? Is it a standard deviation? Is it a mean? Is it a proportion?
Proportion.
It's a proportion. So what's the claim?
Change in diet, change the percentage of milk fat.
It's changed. So it used to be 3.72, and now they're saying it's not 3.72. They didn't say if they think it was higher or lower. They took the chicken shit route out. A real, tester says, I think it's higher or lower. None of this, I don't think it's the same anymore. This is the chicken shit way out, but they took the chicken shit way out. Unfortunately, that link doesn't work anymore. When I made this, it did. I should try to do the link this morning and it didn't work. Rude. I think they redid the experiment. For every inch increase in standard deviation of plant-to-plant spacing, the corn grain yield rate drops approximately 2.2 bushels per acre. I realize Zoom got a little glitchy looking. There we go. It's back. That's true. I got it from a Purdue University study on corn grain yield. The next thing I made up. I can't get away with lying about this. We fucking neared the World Ag Expo. A new corn planting machine revealed that the World Ag Expo claims it has decreased the standard deviation below that of its former model, which had a standard deviation of 4.5 inches. What parameter are we talking about here? We're talking about the standard deviation. What's the claim? What did it used to be, and what do they think it is now?
2.2.
Close. Not quite. .2 is about bushels per acre. The standard deviation is about inches. So they're not the same even quantity of the units.
Then you have to find out how many inches are in an acre.
No, that I'm not throwing math at you right now.
We don't know what it is now, but it was 4.5.
It was 4.5. So the standard deviation was 4.5. They're saying it's lower. So it's less than. The standard deviation is now less than 4.5. That's what their claim is. The average final exam score for students is 73%. I pulled this from the semester I made the slides. And we believe the use of computers in statistics courses, like using StatCrunch and shit like that, will improve overall grades, raise your average final grade. What parameter is this statement about? Talking about proportions, standard deviations, means, variance. Mean, why do you say that?
Because it's an average.
It says average. It is a mean. The percentage might throw you off because we usually have percentages for blah, blah, blah. For proportions, we usually have the percentages, but that's actually what we're taking an average of. So it is an average. Average means mean. We are talking about a mean. What's the claim that we're making? The old mean used to be 73%. What is our theory? The average increase, what's that mean in terms of like math jargon? The mean is what compared to 73%? It's greater, larger. So this is how hypothesis testing works. It's a procedure that we use. It uses probability and sample evidence, and we're choosing between two competing hypotheses. And I've got examples listed for each of the ones we just did, so you'll see them a little bit better in a second. Let's just talk about what we label the two hypotheses as. One is labeled as the null hypothesis. It goes with an H0. Or H naught is another way of saying it. It is the claim that we assume is true. So it's usually like pre-existing information. Like stuff we've taken, like they did studies in the past and we think that's what it is. So the null hypothesis, H naught, is what used to be or what we think is the reality. In the card game, it was the probability that black was 1/2. It is a statement of equality. The null hypothesis will always have an equal sign, as you're about to see. The alternate hypothesis goes by HA. Sometimes it goes by H1, depending on every once in a while. They use different ones for some reason. I think they did H0 and H1 because like 0 and 1 go in order. But like they kept H0 and went with HA for alternate, I think. And they didn't relabel H0 to HN like they should have, like H null and H alternate. But it's a statement of inequality. It's got your not equals, it's got your less thans, it's got your greater thans in there. It doesn't have an equal statement in it. So the one we talked about, milk fat, is here. H naught, the proportion was 0.0372. And the new claim is that it's no longer 0.0372. So we have a not equal to. When it says it's different or it's changed, but they don't say how, they don't say if it's gone up or down, we just say not equal to. This is called a two-tailed test. When we start going into it and I show it compared to like a bell curve, we have both sides of the bell curve are like grayed out kind of thing. We're only looking at stuff in the middle of the bell curve usually. That's a two-tailed test. There's a left-tailed test. This was on the standard deviation. The null hypothesis, H naught, the standard deviation equals 4.5. It's always an equals for the null hypothesis. The alternate said it had decreased, which means less than. So standard deviation is less than 4.5. If you look at the standard deviation, the less than symbol, if I put like an arrow on it, it looks like an arrow pointed left. That's the way to remember it's a left-tailed test. It's actually pointing to the left side of the bell curve. As we'll see later on. And I don't remember clicking next slide. Fucking that's spooky. Talk about spooky, this shit's changing itself. Right-tailed test is when we have greater than. It looks like an arrow pointing to the right. Right there, pointing to the right. The one we did was about the students' grades. The null hypothesis is the equal portion. It's the previous one. It was 73%. That's what we assumed to be true. That's what it was. How do we know? Because we fucking collected evidence and we took the grades of students and averaged it. We think by doing the new procedure, it changes it. And so, and not only changes it, but it goes up. So the alternate has a greater than sign. So there's three ways these turn out, like the not equals to, the greater than, or the less than. It's really the choices you have. This points to the right side of the bell curve, as we'll see. We're not doing it today, but we'll do it on Thursday. So there are two outcomes to hypothesis testing. So, well, there's two good ones and there's two bad ones. The null hypothesis, though, is much like the statement of not guilty in a criminal trial. We assume it's true until proven otherwise. Like, we assume the defendant is innocent until proven guilty. And then the alternate idea is that they're guilty. We are very much biased in the jury system, or the law system. We can make mistakes. There's mistakes made all the time. We will make mistakes in statistics as well. We are not collecting all the information for the entire population. We're just doing a sample because it's too hard to do the entire population. So when you're just doing a sample, your sample could be deviant. It could be an outlier, and you just don't know it. We still got to base it on our sample. But we try to err in favor of a specific thing. In the court of law, we err in the favor of the defendant being innocent. We assume they're innocent until we prove otherwise. But what does the jury and the judge always say? They don't say the defendant is innocent or guilty. They say the defendant is guilty or not guilty. Because we don't know. There might be some Lex Luthor criminal fucking mastermind that's figured out how to fucking kill someone with no DNA evidence, have a solid alibi, avoid all cameras, have no way to prove that they murdered someone or more than someone. Maybe they're like a skilled mass murderer. Maybe, and they're just good at it. They're good at what they do. They're Dexter Morgan. They're fucking good at murder. And you just can't catch them. It doesn't mean they're innocent when you try them and you don't find any evidence. You don't find enough evidence. It just means you haven't collected enough evidence to support them being guilty. If you were able to, the verdict might change. So we never say they're innocent because that may be false. They're just not guilty. which sounds like it's a fine line to walk in like law, but it's applicable. Because they might actually be guilty, but we just haven't declared them guilty. We don't know if they're innocent. This is the same thing in statistics. We are not going to know, I don't know why I'm emphasizing with a hand slap, we are not gonna know if we're right or wrong. But we're gonna try to set it up so that if we are wrong, it is very unlikely. And you'll see how. That's how that's how the statistics process works. We're gonna try to avoid that, but there's still room for error. Every once in a while, we do convict someone that's innocent. In fact, it happens a little bit more often, depending on what nationality and skin color you are than otherwise, which is fucked up. Then all of a sudden, personal bias is coming into the court of law. That's not really right. We need like an AI judge that's fucking fair. So, like, this doesn't have personal biases, isn't getting on that seat and like, no, I'm a good guy, I really know, but I hate black people all of a sudden, you know, like they don't say it. And they're just, nope, but you're convicting black people left and right. No, it happens.
Did you know that judges actually give harsher sentences before lunch because they're angry? Like a real thing.
Ah,
That after lunch, people who, after they've eaten the judge, the verdicts that they give are much more lenient than.
don't they eat
hours
breakfast? They don't eat breakfast?
I guess not. But that is like that's a real thing, that they give a lot harsher sentencing because
I
they
know
haven't
it's
eaten lunch yet.
everybody though.
That's interesting. Is it lunch or is it like they're just not like morning people and it's feels so like the coffee hasn't completely kicked into? Do you ever see a judge drinking coffee? I don't know. They must drink something. Huh. I had to put up jury duty this week. This was great. All right, quick deviation from the slideshow. So, I live in Tulare. The Visalia Court of Law is much fucking closer to my house than Porterville. The Tulare court closed. And they said, Visalia gets enough people already. You don't get to go to Visalia. You get to drive your happy ass to Porterville. Last time I went, they had us there for 2 hours. We didn't even start the jury selection. They're like, come back tomorrow. I'm like, motherfuckers, I drove, I had to drive a ways out here. Next day, like, they were ready, and then they decided to send us a lunch for like, not an hour. It was like fucking 2 hour lunch. And then come back and then like do the jury selection. And they dismissed me. This time when I called in, because I can get as a teacher, I can say, my job affects like 200 people's education. I don't want to get out of jury duty. I actually like jury duty. I just want you to make it so it's at a time when I'm not fucking over all my students by going to jury duty. So I tell the lady, my finals are over like halfway through December and I start about halfway in January. Can I do it between like December 15th and January 15th? She's like, well, let's see, I can extend it 3 months. And I'm thinking, bitch, it's fucking late October. 3 months is late January. I'm in the next fucking semester. Pay attention to what I'm fucking saying. You're not fucking being helpful. And then I asked, well, can we do it like, what about the week of the 15th? Nothing. What about like, they don't apparently have a lot of, maybe the judges go on vacation or something during Christmas and New Year's. Not even the first week of January was in. I get to do it January 8th, which is like, it gives me 1 week for jury duty. And if it's going to take longer than a week, I have to tell them you're leading into the next semester and cancel me. But I bet they fuck me over again, make me go out there and wait fucking just a few hours for nothing. To check in and come back the next fucking day. We don't all fucking live in Porterville, jackass. I hope that one of you fucking council people that does the jury thing, you fucking watch this. Does anybody work for those motherfuckers? Let them know. They're assholes. Quit doing shit like that. It's actually the judge that chooses it. It's not like the people that work for him. It's the actual judges. The judges decide when everything happens. And the judge was a fucking asshat.
There's a judge that works just right down, like, the end of this hall. He works for Porterville.
Does he still?
Yeah. I had his class last semester.
Really?
He's like a legit judge. Very dumb.
Mine was a she, so it wasn't the same one. Not all judges are, I'm not stereotyping judges. I'm just saying, the last judge was that, and then this time when I called in, I got like an incompetent person on the other end of the fucking phone.
Yeah.
All right. Back to hypothesis testing. Sorry about the rant. So the outcomes we have, we can reject the null hypothesis. We want to reject the null hypothesis because if it's true, it would be unlikely. It would be surprising. By the evidence we've gathered, it feels unlikely. Now, before I flipped over the deck and showed you the red cards, it was feeling pretty unlikely that that deck was fair, right?
It wasn't shuffled.
I shuffled it and you were drawn in the middle. It's not like I fucking flipped over all the black cards on the top. But it would be if the null hypothesis is true, it's unlikely based on the evidence. So the evidence you had was like, it doesn't look like the deck was fair. Because you drew black cards and black cards only, that's suspicious. And so we would say that there is sufficient evidence to reject the null hypothesis and sufficient evidence to support the alternate hypothesis. And that's what this is about. Our statement of confidence is always going to be about the alternate hypothesis. I need to edit this slide so that it says that. There's sufficient evidence to support the claim that the alternate hypothesis is true. Whatever it is, you want to like put in words. We'll see that a little bit. If we fail to reject the null hypothesis, that's the other option, where if it is true, it's not surprising. Like if you had drawn half red cards and half black cards, you wouldn't be shocked to find out that the deck was fair, right? Because you drew half and half. It met what you suspected. So we wouldn't reject the null hypothesis, and then you would change it. Like if you drew 3 black cards in a row, and then you were starting to get suspicious, and then the next 3 cards were red, then you'd be like, all right, maybe I'm wrong. Either way, it's about the alternate hypothesis, the statement we're going to make. We make our decision on whether or not we're rejecting the null hypothesis. Also, at the same time as whether or not we can support the alternate hypothesis. You'll see that in a second when we go over the steps of the hypothesis testing. We do have some bad juju errors. We can make mistakes. Rejecting the null hypothesis when it's true. This is like convicting an innocent person. They're innocent, the system says they're innocent, and the jury got a wild hair up their ass that said, nope, you're fucking guilty. Or the judge did. Judge says, you're black, you're guilty. Racist judge. No judge says that. That would be, they'd get fucking de-seated, lose their fucking law license really fucking quick if they just said, you're black, you're guilty. That's fucking terrible. I would hope to God they would get kicked out pretty fucking quick. Hopefully the judge down the hall isn't a racist. He's not hearing me yell judge shits or judges are racist. Because I'm just giving like an example of when they are misdone. So that would be an error, like judging someone, putting them in jail when they're not guilty. The other one is not rejecting the null hypothesis when we should. When there's enough evidence to say, nope, that motherfucker did it. And we said, that's not enough evidence for me. I'm gonna let that motherfucker walk. But his fucking fingerprints were there. He had blood on his fucking face. He's got a fucking history of violence. We're gonna let him walk. All the evidence. So this is rejecting or not rejecting the null hypothesis, not saying, failing to go, nope, they're not innocent. That's like letting the guilty walk free. Now, we lean towards one of those two things in the court of laws. We lean to, because either of them can happen. You never really actually know. Even video footage can be faked. Like you can fucking frame somebody for a crime they didn't commit with erroneous video. There's like, it's easy to, no matter how dead solid you might think your evidence is, you might convict the wrong person. For whatever reason. So we try to avoid that at all costs. The assumption that they're innocent until proven guilty is designed to protect the innocent, even if that means sometimes guilty people walk. Because you have to have enough evidence, and it might be clear as day to everyone in the fucking room, that motherfucker did it. He's fucking giggling about it. Every time you talk about, like, you show a slideshow of how the person's body is, and he's looking at it and his mouth's watering, he's like, yeah, that looks nice. You're like, nope, that motherfucker did it, but you can't prove it. You can't convict him. So sometimes the guilty walk free. We'd rather do that than have someone innocent serving time for a crime they didn't commit. Okay. We assign an error type to them. Alpha is convicting the innocent. Beta is letting the guilty walk free. We lean towards making alpha, the A, this one, look as low as possible. So we want alpha to be low. Usually we go with like 5%. If it's something really, really important, we go 1% or even 0.1%. I'll do some numbers out on paper a little bit. If it's not important, we might say 10% or 20%. If it's like, my algebra class is pretty sure that they're going to stop stocking chips in the vending machine because every time they buy chips, another chip bag falls out and they're losing money on the chips. So they think they're going to stop stocking it. And if they did this hypothesis test, they could fucking go with 30% hypothesis test because there's no consequences if they're wrong. If you're doing something and you know where an error is fucking terrible, like convicting the innocent, or like, let's say you're a surgeon and you fuck up, like a 5% error rate isn't all that good for a fucking surgeon. That means 1 out of every 20 people, he fucks up. That's not that good. I don't know that if I'm going into something that might be a fatal surgery, if I'm willing to risk it with this surgeon. So I might want 1% or even 0.1% or something where it's like, all right, someone might die on his table, but it's going to be an accident. It's not going to be neglect or some shit like he did. We call alpha the level of significance. We want to make it small or severe consequences. I think that made the last slide. It is. All right, let's go over a little bit more information on that. This thing right here. Ten point one, it's an hypothesis testing. I will upload the slides, but I want to throw a little bit down on paper for a quick summary. H naught is called the null hypothesis. It has an equal sign in it. Whether it's probability equals something, the mean equals something, standard deviation equals something, it's an equal sign. It's called the null hypothesis. The alternate hypothesis goes by HA, sometimes H1. It's called the alternate hypothesis. This has an inequality in it. I'll just list P. But P could be not equal to, it could be less than, or it could be greater than that sum value. And P could be mu, or it could be standard deviation, one of those. But it has one of those inequality symbols. We have alpha is called the level of significance. %5 or 0.05 is the default setting. If none is given, use 0.505. Anyone still writing? Okay. No rush. Alpha is related to our level of confidence. It's related to our confidence interval. CI. For a two-tailed test, where HA has the not equals in it, the confidence interval is 1 minus alpha times 100%. So if alpha equals 0.05, confidence interval is 95%. For a one-tailed test, whether it's left or right, we're going to use 1 minus 2 alpha times 100%. So like alpha equaling 0.05 if you plug that into the meat grinder, it gives us a confidence interval of 90%. So if we're okay with looser guidelines, we don't need it as, if the consequences are mild. If consequences for error is mild. We might use alpha equals 0.10 or even up to like 20%. Or somewhere in this range. You can go, it can be greater than 0.05 is what I'm saying. Really just alpha can be greater than 0.05. You pick something higher. But if consequences are severe or dire, we want alpha to be as low as possible. Alpha equals 0.01 or even alpha equals 0.001, which would be 0.1%, is not unheard of.
Failed. The alpha still is 0.05. Like in the last one more.
It depends on what your alpha is.
Okay.
You're gonna plug alpha in. We choose our alpha. We choose alpha. Like for your problems, they're gonna choose alpha. But in the real world, when you're doing a hypothesis test, you get to choose alpha. The default is 5%. Because like 5% is what we consider unlikely if it gets in the 5% region. And we want like an error to be unlikely.
Okay.
All right, so 10.2 and 10.3 we're gonna do on Thursday, but I want to introduce the steps of the hypothesis test today. So there are 5 steps to the hypothesis test. Let me pause and make sure that everyone's done with that other shit. You guys ready? Step one. Identify your two hypotheses. The null or H naught and the alternate. HA. So for example, with the card thing, we thought the probability was 1.1/2 or 0.05. And at some point that you guys thought that the probability of getting a black card might actually be higher than that or lower than that. Higher than that. You thought it was gonna be higher because we weren't, that's all we were getting. So this would be H naught and this would be HA. Steps 2 and 3 are kind of interchangeable. Two is find the test statistic and p-value. This is a StatCrunch thing. It's really fucking easy. It's easier than pi. I don't know why they say easy as pi. That seems like it's making pi is not as easy as they fucking describe it. As easy as a pi would imply. This is easier because if you've been doing your homework for like chapter 9, the confidence intervals, it's the same way. We had to click off of hypothesis testing to choose confidence intervals when we did proportion stats and we did t-stats. So you'll see. And when you do them, they will give you the test statistic and they'll give you the p-value. So it's like pretty straightforward from there. The other one is identify alpha. If none is given, use 0.05. We're not doing the card game thing in StatCrunch, so I'm not going to give an example how that relates here because we don't have that. And we'll be doing this a lot. You'll see these in examples for the rest of the semester, I promise you. So if it doesn't make sense now, it will.
What is on number 2, find the test stat? Is that an and sign or is that?
And
Okay.
ampersand. All right, let's do 4 and 5. These are the ones that are a little bit longer. 4, we are going to compare the p-value to alpha. There's 2 outcomes to this. One is the p-value is less than alpha. When that happens, we reject H naught and we support HA. Option B. The p-value is greater than or equal to alpha. We do not reject H naught. And we do not support HA. Okay, so what's an easy way to remember this? This will catch, this will stick, you're gonna like it. Are you with me, Michaela? The p-val's too low. Reject the hoe. It's really H0, but it sure as hell looks like hoe. I don't even know if that's how you spell hoe. Like the gardening implement is HOE. How do you spell hoe when you're talking about Santa? It's HO, right? Yeah, you thought I was gonna say something else right there, didn't you? I'm not gonna talk inappropriately in here. All I know is that my morning class, there was one student that dressed up, and she dressed up as a cow. And she did it for extra credit in the dairy science class, where they were gonna be talking, they were recently talking about milking cows, and I'm like, this seems inappropriate at best. Like, how do you milk a cow? You're dressed as a cow. Don't you think this is a little wrong? If you watch this later, Cassie, cheers. All right. How do you remember this one? There's no real jingle. This is the jingle you got to remember. But the way you remember this one is p-val is not too low. We do not reject H naught. We do not support HA. And when we see step 5, there is not enough evidence to support HA. To support the claim of HA. That's in our step 5 in our statement of confidence thing. The knots go together. And if p-val is too low, reject the hoe doesn't work for you. There's another one. It's a fucking lame one. What is it? If the p-val is too low, the null must go. That's fucking lame. But if you like the lame version, you don't want to say reject the hoe, you could say too low, the null must go. I like that one. That's just me. Step 5 is, who the fuck is dressed up as one of the Incredibles over there? That's shit. It's all ripped. Step 5 is our statement of confidence. Well, is it a comment? Statement of conclusion. I'm so used to saying statement of confidence. Concluding statements. So for option A, if we reject H naught and support HA, our sentence is about supporting HA. That's what we want to say, like you're gonna, if you're doing this in real life, you'll have some article or presentation you're doing. You want to say something where you sound intelligent about it. There is sufficient evidence or enough evidence. To support the claim. In the case of the card game thing. That Hefe is a cheating bastard and he stacked the deck. You want to say something about whatever the claim was. B, where we do not support HA. Like if the p-val is greater than alpha. This doesn't really change it a whole lot. We can you can actually use the exact same sentence. Add the word not. Add the idea of not. There is insufficient evidence. Or not enough evidence. Blah, 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 and you want to say, like, when you're doing it, you can actually oftentimes just quote the actual question, you just copy and paste it. I do have one thing I'd like to confess to you. While that was the deck I showed you, that was not the deck we used. It was stacked against you. The point was, though, that you don't know. You're never gonna know whether or not your hypothesis is 100% correct.
So when did the lecture with 6 black ones?
Yeah. Kind of a giveaway, right?
Not so spooky after all.
Not so spooky after all. It's not coincidence. This morning's class, the fucking first student drew, they had the red deck. I never know what it's gonna be until I open the first one. Like to avoid the whole cellophane thing, I undo the bottom. And I tape the bottom back up. And then I can unwrap the fucking cellophane, pull out a fresh deck. But when I do it, I don't know which I'm getting. So I have both versions of the slideshow set up with black and red. And they had red cards, and after they drew, they wanted black cards and they had all red cards. First student, after one red card, said, I want to see the deck. You're cheating. I'm like, God damn, that's a bold claim with me being your teacher. That's pretty enough. So like I was giving him shit all day. And then I showed him none of them said, it says 6 cards in a row. That's pretty suspicious. Why does the slideshow already set it that way? None of them made that observation. They wanted to know, they demanded to know, show us the deck. They asked for fucking like an hour and a half. I'm like, there's a presentation here. The idea is you don't know. All right, we will do more with hypothesis testing on Thursday. We'll do 10.2, 10.3. Have a happy Halloween. Get the fuck out. They Googled it. You could buy stacked decks. I'm like, you think I'd pay extra for a stacked deck? I got a box of bicycle cards in my office. I jury rigged these decks yesterday. Happy Halloween, Maritza.
I gotta stop recording.